Hello, everyone. Welcome back. Today, we'll learn about something called the mean value theorem for integrals. First, we'll understand what it is, what it tells us, and also, since it's talking about a mean value, we're talking about an average. We'll be able to find this, use this to help us find the average value of a function on an interval, which sometimes can be useful information. So first off, let's take a look on the left. So here's our, what's called the mean value theorem. It says if f is a continuous function on some interval a to b, and there's some point in the interior, meaning not including the endpoints, c, then basically that if you integrate this function over this integral from a to b, and then just divide by the length of the width of this interval, which is b minus a, then that's going to be the average value of the function f at this point c. There's some point c that's going to give you that function value. Okay, so that's a little wordy, but let's kind of explain over here what this means. So let's just take a look at a basic function. So here are our bounds. Here's a and here's b. Let's just say we have some function looks like this, kind of a standard function like we like to draw. This is our function f of x. Okay. Now, of course, we know that the area under the curve from a to b, that, of course, is the integral of f of x from a to b. Okay. And also this distance here from a to b, if you do b minus a, that's this distance, that length. Okay. For example, this is from 3 to 5, this is 5, this is 3. 5 minus 3 is 2. We have a length or width of 2 here. And what this says is basically there's going to be some average function value here, okay, on this interval. And it's going to be some point c. We don't know exactly where it is. Okay, it doesn't have to be in the middle or anything. It could be some point c, so that f of c, that y value, is the average function value. What that means is that if you actually created a rectangle, let's actually change colors here. Let me change to red. If you actually make a rectangle which went from, has a height of f of c and a length of b minus a, that this area is the same. Okay, that's what this means. So to be an average, oops, sorry about that. What that means is area f of c, which can also be called the average of f, that's what the line means, is the average value then the integral of a to b of f of x dx, okay, is equal to this rectangle I've just drawn, which is basically b minus a times f of c. Okay, and actually that's where this comes from. If you divide both sides by b minus a, you get this value right here. Okay, and I actually realize, let's come back over here in a second. This should actually be, just instead of t, this should just be an x. It doesn't really matter that much. You can use t as a dummy variable, but there's no real need to right now. Okay, but I said a lot of things right here. So this f of c is the average value of the function in this interval from a to b. And of course, if you change the interval length from different a's and b's, you get different averages. And once again, the area under the curve of f of x between a and b has the same area as this rectangle. So that's what this means. Okay, that's our average value. Let's take a look at a couple examples to find this. See how we use this in practice. All right. So number one, I have to find average value. Okay, and let's say our function, our f of x, is going to be x squared plus 1, and our interval is going to be on the interval from -2 to 2. Okay. Now, we'll draw this on Desmos here in a minute. Basically, what it looks like is something like this. So you hope you recognize x squared, of course, is a parabola. Plus 1 means it's shifted up 1. And so from -2 to 2, it's basically going to be, looks like that. Okay, so I want to find the average value on that interval. So let's go to Desmos real quick. We'll see the same thing. So y equals x squared plus 1. Right. And also, if you, between -2 and 2, it's not as easy to see. We can also just write in do final lines. X equals 2 and x equals -2. Okay. And also, you can see where those lines intersect right here at -2 and 5 and +2 and 5. Okay. And of course, here we're talking about if we integrate, it'd be this area under there. All right. So let's find this average value. Okay. So first, let's integrate this. So the integral from -2 to 2 of x squared plus 1 is dx. Okay. So we're going to do this as this is a definite integral. So integrate x squared, that's going to be x cubed over 3 plus, and integrate 1, that's going to be x. And then we evaluate this from -2 to 2. Okay, and we do that. And so just replace the first one with 2. So 2 cubed over 3 plus 2 minus, then replace the x's with -2 is -2 cubed over 3 plus a -2. Okay, here now number 2 cubed is 8, so 8/3 plus 2. Then that's going to be minus, and -2 cubes mean minus 8/3. Actually, then here we have -2. Okay, we're going to distribute the negative. And so we have 8/3 plus 2, and that's actually plus 8/3 plus 2. Okay, and so we just have to combine those, and so it's going to be 16/3, and write this as plus 4, and let's write 4 is something over 3, and so 16/3 plus this is 12/3, and then finally that's going to be 28/3 doesn't reduce. And remember, that's not our final answer, that's our integral. Okay, and also b minus a is going to be 2 minus a -2, which is 4. Okay, so the average is going to be 1 over b minus a, which is 4, times this integral we just did, which is 28/3. You notice 4 goes into 28 7 times, so this is going to be 7/3, which is approximately, I should believe that I have 7/3 is going to be basically 2.333 repeating. Okay. Now let's go back and look at our graph on Desmos. Okay. And so y equals 7/3. So, but it's basically saying, we imagine take this integral, okay, if our original function, let's turn this one off, okay, from -2 to 2, we get this kind of interesting shape. And that way, have the same area, if we just, this area of this rectangle right here we see, which is a height of 2.33 and goes from -2 to 2, those would be the same areas. That's the average value of that function on that interval. Of course, once again, if you change the function or the interval, you get a different result. That's the average value of that function. Sometimes the average value is useful to know. Like the averages are often useful to know. Okay, let's do one more. For 2, and find the average value. All right, so let's just do f of x equals cosine of x on the interval, I wrote of again, on the interval, -pi/2 to pi/2. Okay, see what we get. All right. So once again, similar things we had. Doesn't matter. Let's actually do the b minus a first. Doesn't matter, but that's going to be pi over 2 minus a negative pi over 2, which is going to be pi over 2 plus pi over 2, which is, of course, just going to be pi. Okay. Now, the integral from negative pi over 2 of the cosine of x dx. Of course, that's just going to be, remember that what function gives us derivative of cosine, that's going to be sine. So the sine of x evaluated from negative pi over 2 to pi over 2. And so that's going to be the sine of pi over 2 minus the sine of negative pi over 2. Okay. And if you don't remember, now also you can use Desmos to help you out with this as well. Let's go back to Desmos. So as far as a picture, didn't do a picture. So let's actually turn all these off. So y equals cosine of x. From negative pi over 2 to pi over 2, you can see it's actually right here. I should have drawn that. Let's go back over here and do that really quickly. Our picture looks something like this, where you have kind of a parabola, very similar to a parabola shape right here. Of course, this is negative pi over 2, and this is positive pi over 2. Okay. Now, if you don't remember what sine of pi over 2 or negative pi over 2 are, you can actually use Desmos to help you out with that. Remember, we're default in degree mode. Right, to change that is go to the little wrench here. Right now, we're default in radian mode is what we want. We're in radians. So if we do sine of, and to type pi, just do pi divided by 2. That's 1. Then actually, if I just change that and make that negative, yeah, it's negative 1. Okay, so that's something you always do instead of going to your graphing calculator. And so this is going to be 1 minus a negative 1. And of course, that's going to be 2. Okay, so the average value, F average, is equal to 1 over b minus a, which was pi. And then this average value is 2. And so this can be 2 over pi. Okay, now that is also, let's see, approximately what is that? That's one. Use your calculator or also use Desmos. That's when we don't run across very often. About 2 divided by 3.14. So 2 divided by pi is about 0.636. So let's actually graph that. So y equals 2 divided by pi. And if we zoom in, what it's saying, if we went from negative pi over 2 to pi over 2, okay, where cosine is equal to 0, right here and here, and made a rectangle with this height of about 0.637, that rectangle had the same area as the area under the curve of cosine from negative pi over 2 to pi over 2. That's about 0.64. Okay, but so that is how we do, that's how we find the average value of a function over an interval. All right, so that's the idea of the mean value theorem. That's what it does. So it helps us to find then the average value. Have a good day.